Hey you guys, and welcome to the next episode of Mathematical Mowbray Movies. I know you've been hanging out for this one and wondering what's going to happen next. What are we looking at next? Well, I'm relieving you of your anticipation and telling you that we're looking at Pythagoras' theorem. No, sorry, Pythagoras' theorem. Get it? Just trying to keep you on the ball there. I'm going to crack some lame jokes throughout these little videos so that you hopefully stay awake and enjoy some quality evening viewing. You can laugh at me, you can laugh with me, I don't care either way, as long as you keep watching. Let's get straight into Pythagoras' theorem. Hopefully you remember a little bit about Pythagoras' theorem, the main thing being that it relates to right-angled triangles. So it's a triangle that's got the little right angle symbol in the corner. The next thing you need to remember is what we mean by the hypotenuse. Now the hypotenuse can be remembered as either the longest side or the side opposite the right angle. So if I look at this triangle here, which is the longest side? Well, hopefully you can see it's this side. So this would be my hypotenuse. Or using the other technique, the side opposite the right angle, well here's my right angle, so the side opposite the right angle, again, it's this side. So you can remember it using either of these two techniques. In any case, you need to remember that this is the longest side and that is the hypotenuse. In Pythagoras' theorem, which I've written here, there's the letters C, A and B. You need to know that the letter C always applies to the hypotenuse. A and B are the shorter sides. It could be A and B or it could be A and B. It doesn't matter. I tend to write A and B, but you can do whatever you want as long as you have C applying to the hypotenuse, so you must have that. Now you don't quite get this formula on your formula sheet, but you get one similar called the cosine rule, and it looks like this. So you get this on your formula sheet, and the first bit of it, if you get rid of that bit, this first bit of it is Pythagoras' theorem. So you kind of get it on your formula sheet, even though you don't get it directly. So what do we use Pythagoras' theorem for? Well, it's got three sides involved in our formula, and so we use it when we're trying to find a side and given two other sides. So we use it when we're trying to find one side, when we're given two sides. So that's when we use Pythagoras' theorem. Now that's going to be a little bit different to when we use trigonometry, which is going to involve some angles. This has got nothing to do with angles apart from knowing that's a right angle. This is all to do with the lengths of sides. So we use it when we're trying to find one side given two sides. Sometimes the side that we might be trying to find will be the hypotenuse. Other times it might be a shorter side. So if I was given A and B, they might ask me to find C, the hypotenuse. On another occasion, they might give me C and B and ask me to find A, for example, or they might give me C and A and ask me to find B. That would be finding one of the shorter sides. Our formula directly, as it's written, Pythagoras' theorem, that doesn't actually allow us to directly calculate one of these sides. We need to do a little bit of rearranging. And the hypotenuse is the easiest one to rearrange. So remember, we're trying to work out, in this case, what C is. So our formula says C squared equals A squared plus B squared. Well, we're just trying to find C on its own, not C squared. And so what we need to do here is get rid of that squared sign by using the inverse operation, which is square root. So to get C on its own, we're going to do the square root of A squared plus B squared. So that's going to be the formula that we'll use if we're trying to calculate the hypotenuse. I'm going to write it here and put it in. I'm going to put these in brackets because when you do it on your calculator, you need to do that. So this is the formula we use for calculating the hypotenuse when we're given A and B. For the shorter sides, it's not quite as straightforward, but it's pretty straightforward still. So our original formula was C squared equals A squared plus B squared. In this case, we're trying to find A or B though. So to get A squared or B squared on its own first, we need to move the other one on the other side. Now these are both adding, so add B squared. So to move it to the other side, we use the inverse, which is subtract. So if we're just trying to get A squared on its own, this is actually going to become C squared minus B squared, since This was adding b squared. We take it over, it becomes minus b squared. And I'm not trying to find a squared, I'm just trying to find a, the shorter side. Again, I need to get rid of that squared sign by square rooting. So that's my formula for calculating the shorter side. I'm going to flip it all over and write it as a equals the square root of, I'm going to put those brackets in again, c squared minus b squared. So these are our two formulas. To find the hypotenuse, we do the square root of the squared side of the sides added together. To work out a shorter side, whether that's a or b, I do the square root of the hypotenuse squared minus the other side squared. So what are the key differences here? Well, in this case, there's an addition of the two shorter sides squared. In this case, there's a subtraction, but just notice that I'm always subtracting from the hypotenuse squared. So the c has to come first here. So let's give it a go. Here's our first example. In this case, I first of all have to work out, am I trying to calculate a shorter side or the hypotenuse? Well, I have to look at my triangle and see, well, which is the hypotenuse? And in this case, this side here is my hypotenuse because it's longest and opposite the right angle. So here I'm trying to calculate the hypotenuse. So I'm going to need to use my formula for calculating the hypotenuse. And that formula is this one here. So that's the first thing I do, is that I write down my formula. C equals the square root of a squared plus b squared. Now I substitute in what I know. I'm going to label these sides. Well, I always know my hypotenuse has got to be c. So I know that my x is actually c in this particular case. A and b, like I said, doesn't matter which ones you choose to put it as. So let's substitute in. Well, the square root of, my a was 4, so I'm going to replace the letter a with 4. Leave the squared as it is. B is 5.5 squared. Close my brackets. I need to get my calculator out. And I plug it straight into my calculator. It's a bit glary, sorry for you guys. There's better, there's a bit better. So, yeah, there's better. So I'm just going to, like I said, do the square root. Remember, I need those brackets in order to make my calculator do the full calculation. So I did 4 squared plus 5.5 squared, close brackets, equals. So in this case, to one decimal place, this is 6.8. What I'd like you to do now is to have a go at calculating this one for yourself. And you need to put the answer into the little window that will pop up in just a moment. Okay, how did you go with calculating that one yourselves? Let's give it a go and check your answer. Again, in this case, we're trying to calculate the hypotenuse, the side opposite the right angle or the longest side. So we need to use that same formula. C equals the square root of a squared plus b squared. I plug in my numbers. A is 7, well, I'm going to call this C first because always the hypotenuse is C. A and B, remember, it doesn't matter. I tend to just do them left and right for some reason. So A is going to be 7 here. B is going to be 9 here. Again, I use my calculator, plugging in my numbers, just pull that so you can see. The square root of, don't forget those brackets, 7 squared plus 9 squared, close brackets. Again, rounded to one decimal place, this gives me 11.4. Fingers crossed you got that. Right, okay. Let's now move on to some where we're calculating the shorter side. So remember, these were calculating hypotenuse. These questions here are about calculating the shorter side. So you can see I'm given the longest side, the hypotenuse here. I'm given the side that's opposite the right angle. I'm given the longest side. I'm asked to calculate one of the shorter sides. So in this case, I need to use my other formula. I need to use this formula here. A equals c squared minus b squared. I should have said you can actually rewrite this using b as the subject if you want. you got to make sure you keep your C in the same spot. C's always got to go first. And just like I said, A and B can be switched in the triangle, A and B can be switched in this equation. So this can be, in the place of the B here, I can write A squared. So that's also fine for calculating your shorter side, either of those two formulas. So they're the formulas we're going to use. I'll put them at the top there so you can see them. So we're calculating a shorter side. Again, I need to label my triangle. Hypotenuse must always be the letter C. A and B, it doesn't matter, but it is going to impact on which formula you use. So if I'm going to use the A equals formula, well then I'm going to make sure my unknown is the A, because that's what I'm trying to find. I want A to equal something. If I'm going to use the B equals formula, I'd make this B. So I'm going to label, as I normally do, A and B. It's just how I tend to do it, left to right. So I'm trying to find B, so I'm going to use my B equals formula. So I'll write that formula down. B equals the square root. Remember, it's always the hypotenuse squared first. I subtract, and then I do A squared. I substitute in. This time I know that C is 12. I know that A is 7. And I plug it into my calculator. Here we go again. Oh, it's glary. Sorry about that. Here you go. So we've got the square root. Don't forget the brackets. 12 squared. This time remember it's subtract because I'm finding a shorter side. And subtract 7 squared, which equals, rounding to one decimal place, this is going to be 9.7 because the next digit is a 4. So this rounds to 9.7. Okay, same as before. I want you to have a go at this one yourselves. Type your answer in and then in a moment we'll check it. Okay, let's check this answer and see how you've gone. Same thing here. This is one of the shorter sides since, here's my right angle, this is my hypotenuse. This is also the longest side. So don't be tricked when the triangle gets turned. You've always got to choose the one opposite the right angle or the longest side as your hypotenuse. What letter do I always have to use for my hypotenuse? I must always use the letter C. A and B, like I said, doesn't matter. I'm just going to go A and B. In this case, I'm trying to find this X, so I'm trying to find my A. So I'm going to use the formula that's got A as the subject. So I'm going to use the formula that says A equals the square root of hypotenuse squared, take away the other side squared. Then I just substitute in. C was 22.5, put my square root sign, 22.5 squared. B here is 12.1 squared. Don't forget to close your brackets. My little square root should go a little bit further there. Then I plug it into my calculator and see how I've gone. So we've got the square root of 22.5 squared, take away 12.1 squared. Close your brackets and equals. Now this one's a bit tricky with rounding. I'm rounding to one decimal place here. It's 18.9, but see how that next digit's a 6? That's going to mean that I need to bump that digit up. Well, if I bump the 9 up, it actually ends up bumping further over and it bumps up that 8. So this is actually going to round to 19.0. Okay? Fingers crossed you got that right. Let's try a couple of past HSC questions to see how you go. Here's the first one that I just want you to have a go at. So it says, use Pythagoras' theorem to show that triangle ABC is a right-angled triangle. Well, to show that it's a right-angled triangle means that Pythagoras' theorem would be true. So here this question is really asking you to show that Pythagoras' theorem is true for this triangle. So really what you're asking to do here is I would pretend that you didn't have this side here. I'd pretend that that was your X. Then you're going to work it out from these two and you're going to check that it's 13. And if it is 13, you've shown that it was true. So if I'm trying to find my hypotenuse, oops, sorry, I forgot that little symbol to indicate a right angle. This is my hypotenuse. I'm going to use my hypotenuse formula. And substitute in. A and B, doesn't matter which way I put them, which order. I'm going to make A as 12, so I replace the A with a 12, B as 5, plug it into my calculator, fingers crossed I get 13, square root of open brackets, 12 squared plus 5 squared, close brackets, gives me 13. So what I've done is that I've shown that C, or the hypotenuse, is 13, and so therefore this is a right angle triangle. So therefore Pythagoras' theorem is true for this triangle. So you could say therefore this is a right angle triangle. Okay, these next couple I'm going to, like before, give you a chance to do them on your own before I give you the answer. So again, here's a slightly modified past HSC paper question. It says a triangular sheep paddock is shown. I drew a few sheep in there to hopefully just give you the picture. It says a farmer needs to replace the length of fence joining point B and C. How much fencing will he need? So give that question a go yourself, and then we'll go through it together. Okay, hopefully you went all right. Let's go through it now and see how you've gone. So this here will be my unknown. I've got to say to myself, is this the hypotenuse or is this a shorter side? Well, here's my right angle. The side opposite my right angle is the hypotenuse. The longest side is my hypotenuse. So this here is my hypotenuse, always represented by the letter C. So in this particular question, I'm trying to find a shorter side. I'm not trying to find the hypotenuse. So I'm going to need to use my formula for a shorter side. If I label this A and this B, I'm going to use my formula B equals, because that's what I'm trying to find, the square root of, the formula is C squared minus A squared. Hopefully you're getting pretty used to remembering this formula, but remember it's something that always commit to memory. Then I substitute in. My hypotenuse is my C, 12.5. Don't forget your squared, minus my A, which is 4.5. Don't forget your squared, I almost did. And then plug it into your calculator. So we've got the square root of, open brackets, 12.5 squared. Remember it's subtract because we're working out a shorter side. Close brackets equals 11.66. Now to round it to one decimal place, I've got to say to myself, is this going to stay as a 6 or is it going to bump up to 7? I look to my next digit, it's higher than 5 or 5 or greater, so it's going to bump it up to 11.7. So the fence has to have a length of 11.7 metres. Hopefully you got that one right. Final question that we're going to have a go at, and then you've finished all your homework. Well done. It says, 2 trees on level ground, 12 metres apart, are joined by a cable. So here's the cable. This is again past HSC question. It is attached 2 metres above the ground to one tree. So you can see that the cable starts 2 metres up from this one and 11 metres above the ground to the other. So you can see it starts higher. They're asking us what is the length of the cable between the 2 trees, correct to the nearest metre. Now they'll choose an HSC question where they actually really make sure that you give this correctly, and they'll take a mark off if you don't. So you've got to read the question carefully. All right, give it a go and then we'll go through it. Okay, how'd you go? Let's go through it and check if you've done it right. The first thing here, and it's a little bit tricky, but the first thing here is that you need to realise that I must have a triangle. This isn't a triangle, this is a trapezium, this shape. I need a triangle. So in order to get a triangle, I'm going to need to draw a line across here so that it meets my tree at a right angle. So here's my triangle here, this shape here. I'm just going to draw it below here again. just so that it becomes really clear. So there's my triangle. I know this length here is 12 metres. I don't know this length, but I can work it out. If I know that here to here is 11 metres, and I know that here to here is 2 metres, I know it's not drawn to scale, but this part here must be the difference between the two. It must be 11 take away 2. So I know that this height here must be 9. I'm trying to find the length of this cable X, so I'm trying to find this. This is a right angle, of course, that's where it joined. So here I've got to say, am I trying to find a hypotenuse or shorter side? Well, I'm trying to find the side that is longest or opposite the right angle, so I'm trying to find my hypotenuse, which I represent with the letter C. And so then I use my formula for the hypotenuse. C equals the square root of a squared plus b squared. Again, it doesn't matter which is a and b, I'm going to call them a and b. Square root of, I plug in, my a was 12, my b was 9. I plug it into my calculator. The square root, oh, you can't see it again, sorry. There we go. Square root of, open my brackets, 12 squared plus, whoops, I pressed subtract. The square root of, open brackets, 12 squared plus 9 squared, close your brackets, equals 15. They asked for this to the nearest metre. Well, 15 to the nearest metre is pretty clearly 15 metres. So there's the length of my cable. That's the last question. Your homework's all done. In class next lesson, we're obviously going to work through some questions in the exercise and a few other questions to practice applying Pythagoras' theorem. Well done, you guys. Have a good night.